Lesson 11:8, Angles, Lines, and Transversals. In this lesson, we're going to learn how to identify and find measures of angles formed by parallel lines and a transversal. Now let's take a look at example 1. Identify angles created by parallel lines cut by a transversal. Sarah's building a handrail for a ramp. According to the design plan, the posts must be parallel. How can Sarah determine how the angles formed by the posts and the ramp are related? Well, let's first take a look at the parallel lines. Okay, in this case, we're talking about the posts. So this line R and line S are parallel lines. Okay, those red arrows on that diagram show that those are parallel lines. Line T is what we call a transversal. A transversal cuts through or intersects two or more lines at different points. And then you can see that they have numbered the angles. So you have angles 1 and 2, 3 and 4, 5, 6, 7, and 8. And you'll notice that the angles correspond to each other. And corresponding angles are congruent. Remember, the word congruent is another word for equal. Okay, so those angles are equal. So in other words, when I look at the diagram, angles 1 and 5 are congruent angles. Angles 6 and 2 are also congruent. And then we have relationships like vertical angles. So angles 5 and 7 are the same, and angles 1 and 3 are the same because they are across from each other. And likewise, we have angles 8 and 6 are the same, and 2 and 4 are the same. So what we end up having here is simply relationships that show us how line R and S that goes vertically is related to line T that goes more horizontally. And it also shows us all the relationships that come from those angle pairs. We also have, besides corresponding angles, another group of angles called alternate interior angles. In other words, they alternate from left to right or top to bottom, and they are on the inside of the parallel lines. So you can see the parallel lines R and S here. So angles 4 and 6 alternate on either side of that transversal T, and they are inside that figure. So we call them alternate interior. Same thing with angles 1, that's this one in green, and 7. They alternate also. They are inside the pair of parallel lines, and they're on opposite sides of that transversal T. Then we have what we call same side interior angles. In other words, angles that are supplementary because they are on the same side of that transversal line, or the line that cuts through the parallel lines, and that means their total is 180 degrees. Okay, so let me make that again so I don't cut it out. Okay, so angles 1 and 6 are on the same side of the blue line. They're both above the blue transversal line. They will equal 180. And likewise, angles 4 and 7 are below the blue line, and they are inside those parallel lines. They will also be 180 degrees. So in this lesson, we have a lot of vocabulary that you can use to help you decide the relationship between those angles. So now let's take a look at the try it question. It says, which angles are congruent to angle 8? So this is angle 8 right here. And what angles are equal to angle 8? Well, first look on the vertical side. Across from angle 8 is angle 6. And then let's look at the same position angles on the other parallel line. So what angle is exactly in the same spot along that parallel line and transversal as angle 8? Well, hopefully you noticed that it's the same as angle 4. It's on the bottom left underneath that parallel line. So angle 4 is also equal to angle 8, and the vertical angle to angle 4 is angle 2. So those three angles are all the same as angle 8. Now the question asks us which angles are supplementary to angle 8. Not congruent, but supplementary. So let's look at the angles that are equal to angle 8, such as angle 4. So what angle would be supplementary to angle 4? Well, in this case, it would be angle 5. It's also on the inside of that figure, on the left side of the transversal. Then as we look across, remember angle 2 was equal to angle 8. Okay, so that's this one, angle 2. And what angle is supplementary to angle 2? That would be angle 3. All right, good. And then what matches up with angle 8 to be supplementary along that transversal line? So here's your transversal line. The measures that match up with that are angle 7, because angles 8 and 7 fall along the same line there. And then matching up along that transversal line just above angle 8 is angle 1. Notice that angle 1, okay, is supplementary to angle 4, and angle 4 and angle 8 are the same. For example 2, we now can use these relationships to find unknown angle measures. So take a look at the picture. It tells us that A and B are parallel lines, and they want us to give the measures of angles 4 and 5. When I look at that diagram, I see 8 angles total, and only one of them is given to me, and that is the angle labeled 99 degrees. Or they call it angle 4. I think that that's actually would be angle 8. Okay, but angle 4 is also 99 degrees because it is corresponding to that 99 degree measure. In other words, if you look at your parallel lines, line A and line B, and you look at your transversal, these two angles are on the same position along that transversal. So if I were to slide lines A and B on top of each other, those two angles, the 99 degree angle and angle 4, would match up. Now, if that's the case, I can use that relationship then to find the measure of all the other angles in the picture. So if angle 4 is also 99 degrees, then that tells me all sorts of things, such as angle 6, because they're vertical. We know angle 2 is also vertical, so all of those are 99 degree angles. And then I can use the idea of supplementary angles, like you see right here, to find the measure of the other angles around that. So 180, take away that 99, makes angle 1 and 3 81 degrees, and 5 and 7 81 degrees. So those relationships really do work with the idea of supplementary angles, vertical angles, and corresponding angles. So the measure of angle 7 is 81 degrees, and the measure of angle 2 is 99 degrees. We can also use algebra to find unknown angle measures if we know the relationship between the angles. So for example, you have a set of 3 parallel lines, A, B, and C. The transversal that cuts through them is line T. So look at the angles that correspond to each other. For example, this 75 degree angle is in the same position as angle 6 and angle 10, which means they are all equal angles. So angle 10 is 75 degrees. Now we have an angle that is labeled x plus 25. What we know is that that is supplementary to the angle that measures 75 degrees, angle 10, because they lie along the same line C. So we can use algebra to say the angle measure of x plus 25 plus the angle measure of 75 has to equal 180, and we can solve for x. Now let's try it. In the figure, lines A and B are parallel. What is the value of x? So when I look here at the relationships, I see that the only angle that they've given me is the angle that says 59 degrees. So look at the relationship here and where that angle is and what else it corresponds to. So on the other parallel line, on line A, do you see that the 59-degree angle corresponds to the angle marked 6, which means angle 6 is also 59 degrees. And now I can use that with the angle marked x plus 12, and their total is a supplementary pair, or 180 degrees. Now we're going to solve for x. And x should be 109 degrees. And last we have example 4. Reason about parallel lines. What must x equal if lines C and D are parallel? Explain. Well, in this problem you might notice that the angle that is marked 60 degrees is on the same side of the transversal and in the same position on the other parallel line, 2x plus 10, which means those two angles must be equal to each other. So then we have a two-step equation to solve. Subtract 10 from each side, which means 2x equals 50, and then x has to be 25 when you divide both sides by 2. If x equals 25, then C and D must be parallel lines. So by looking at the relationships, corresponding angles, alternate interior angles, and the same side interior angles will help us determine relationships and also solve problems. Now let's look at the two try-it questions. What must x equal if A is parallel to B? Explain. So in try-it A, we are looking for what x has to equal in this expression, 3x plus 17, in order for those two lines to be parallel. First, I want you to notice that that angle and the angle marked 86 degrees fall inside lines A and B. They also fall along the transversal on opposite sides, which means those two angles, if A and B are parallel, must be equal angles. So we can solve this by setting up an equation. 86 is equal to 3x plus 17. Now we're going to solve that just like we would any other two-step equation. Subtract your 17 from both sides, and 3x equals 69. Then we have to divide both sides by 3, and x must be equal to 23. B. What must x equal if G is parallel to H? Explain. Well, in this case, you don't have the angles on opposite sides of that transversal. Okay, so again, we are assuming that G and H here are parallel lines, and this line M is the transversal. But instead what you see is you see the two angles. They're marked here in red. Those two angles must be supplementary, which means their total is 180. So 100 plus 7x minus 4 must be equal to 180. Now solve that equation for x and come back and check your answer. All right, go ahead and check your answer, and you should have gotten x equals 12. Go to question 15. Line M is parallel to line N, so it gives us that piece of information. Those two lines are parallel. Find the value of x and each missing angle measure. So once I know the value of x, and I know that those two angles that are given, I can use the idea of supplementary angles, vertical angles, and alternate interior angles in order to get the other measures in the picture. So if angle M is 86 degrees, what does that tell me about angle 2 and angle 5? Well, angle 2 must be 86 degrees also, because it is a vertical angle with the angle marked 86. Angle 5 is a vertical angle also, but this one is vertical to the angle marked 2x plus 25. And I don't know what that measure is, except that it is a vertical, or it is an alternate interior angle to the angle marked 86, which means they are equal. So in order to solve for x, I'm going to solve this two-step equation. And 2x must be equal to how much? Hopefully you got 61. Now when you divide by 2, 61 is not an even number, which means you're going to get a decimal. 30 and 5/10 is the value of x. But once you know that the 2x plus 25 is an 86 degree angle total, then that also tells you what angle 5 is. Now, you can use that 86 degree angle and the idea of supplementary angles to get the measure of angles 1, 3, 4, and 6. Okay, remember angle 5 is 86 and angle 2 was 86. So now let's use supplementary angles. If angle 1 and the 86 degree angle are supplementary, then what that tells me is that 180 take away 86 equals the measure of angle 1. So what is 180 take away 86? You should get 94. So that means the measure of angle 1 is 94, the measure of angle 3 is 94, the measure of angle 4 is 94, and the measure of angle 6 is 94 as well. So now you know what all the other measures are of the angles in that picture. Now it's time for you to try some work on your own.